Let's talk about converting from rectangular coordinates to polar coordinates. So let's start first with the point 10, 10 in rectangular coordinates. So my first step is always to draw a picture of that point on the rectangular coordinate plane. So 10, 10 looks like this. It's in the first quadrant. Here's my point 10, 10. And remember, to write the point with polar coordinates, we need an r value and we need a theta value. Well, we have a triangle right here where this value is 10 and this value is 10. So I hope you recognize it as an isosceles right triangle and recognize that that would make this hypotenuse 10 square root of 2. If that's not something you recognize, then you need to use the Pythagorean theorem to find it. But additionally, because we recognize this as an isosceles right triangle, you know this angle right here must be 45 degrees, or pi over 4. I'm going to work in radians today, but you may be doing problems where you need to work in degrees. But this angle right here, I hope is recognizable to you as pi over 4. So our theta is what we're looking for. Remember, when we're writing in polar coordinates, so our r value is 10 square root of 2. And our theta is pi over 4. Remember, there are an infinite number of ways to represent any point when you're using polar coordinates. So I would present this. I think this is the nicest one because r is positive, theta is positive, theta is between 0 and 2 pi, so I would probably present that. But if I needed to represent this point in other ways, I could simply add multiples of 2 pi to this angle right here, and I would have alternate representations. For example, I could write it as 10 square root of 2 comma, and when you add 2 pi to that, you would have 9 pi over 4. So it's just an alternate way to represent that point. Let's do another one. Let's suppose the point is 0, negative 11. So here is our point with rectangular coordinates. Let's graph it. So 0, negative 11 is down here. Remember, finding a representation in polar coordinates means we need an r value and we need a theta. Well, r is the distance from the pole or the origin, right here, to that point. So we can let r be a positive 11. It is also possible you could represent this point with a negative 11. We'll do that in a minute. But for the purposes of these problems, I'm going to use r as a positive value. And if you needed to, you could always convert to a different representation with r being negative. So the distance from the origin to this point, or in polar coordinates we would say from the pole to that point, would be 11. And now I need the angle. Now I can use this angle. I'm going to stick with this positive angle here. We know that angle would be 270 degrees, or 3 pi over 2. So I hope you recognize those just by looking at the picture. That's the benefit of having a picture for some of these. So I would represent the point as 11, comma, 3 pi over 2. If you prefer, oh, I didn't write that as theta. Here's my theta. If you prefer, you could have used theta as a negative angle, right? From here down. And we could have used 11 negative pi over 2. But those two angles, of course, are coterminal and both represent this terminal side right here. I mentioned that I would show you one with a negative r value. Remember, that means we could use this angle right here the angle that is opposite this side, I could use this angle, which would be pi over 2. So if I were thinking in terms of polar coordinates, I would turn, I think about it as if I were standing here at the pole, and I turn and look at pi over 2, and then I would need to go backwards 11 units. So it could be negative 11 pi over 2. That's another way to represent it. Again, of the infinite number of possibilities, here are 3. I might lean toward presenting it this way or this way. This way, of course, is nice because both the R value and the theta are positive. Let's do another one. Let's have the ordered pair in rectangular form be 4, negative 4 square root of 3. So if we graph that one, and I'm always plotting that point when I'm converting, we have negative 4 here, and we're going to go up to, whoop, I did that wrong, positive 4. Positive 4 over this way, and negative 4 square root of 3 down here. So here's our point at 4, negative 4 square root of 3. And again, we can draw our triangle where this length is 4 and this length is 4 square root of 3. And of course, since we're here in the 4th quadrant, I'll label it as negative 4 square root of 3. I hope you recognize the ratio there being part of a 30-60 right triangle. If you don't, suppose you didn't know, and you just represented this as theta, you could write tangent of theta equals negative 4 square root of 3 over 4. And we have tangent of theta equals negative square root of 3. And I hope that now looks familiar to you. And that means this angle right here is negative 60 degrees, or negative pi over 3. I have it represented here going backwards, so I know I was talking about negative pi over 3. We know that negative pi over 3 is coterminal with 5 pi over 3, so that's another option for theta. Now, notice I didn't write the R value yet. Remember, the task is to find R and theta. I wanted you to see that this was our 30-60 right triangle. So if we know this is 4 and this is 4 square root of 3, I hope you know that this side right here would be 8, knowing we have one of our special triangles. If you didn't recognize that, then you would use your Pythagorean theorem to find it. So my R value, I'm going to leave as positive 8. And my theta could be negative pi over 3 or 5 pi over 3. If you're doing problems for a homework assignment or for some application where the value of theta mattered, whether it was positive or negative, or similarly for R, whether it was positive or negative, make sure you pay attention to the directions. Don't ignore it if you're told specifically what theta needs to look like. Let's do another one. Let's say the ordered pair is 5, 2. So here's our point with rectangular coordinates. Our task is again to find it in polar coordinates. I'm going to draw the picture. So 5, 2 be right here. So here's my triangle. This time it's not a special triangle. I hope you recognize with those values. This doesn't represent any of our special triangles. So to find r, we'll just use the Pythagorean theorem. So we have 5 squared plus 2 squared equals r squared. And continue. So r squared is 29, so r could be plus or minus the square root of 29. And again, as I mentioned, I'll probably use my positive r value so that I don't have to get fancy for the problem. But now I need theta. And theta is this angle right here. So we have tangent of theta. Notice that's our ratio. We have the y value and the x value. So we know its tangent of theta equals 2 over 5. And now we'll use our inverse tangent. Theta equals the inverse tangent of 2/5. I'm going to work in radian mode, and I'm going to answer to the nearest hundredth. So inverse tangent of 2/5 is about 0.38. So the exact value for this point with polar coordinates would be square root of 29, comma, inverse tangent of 2/5. But I just found the decimal there, so let's pop that in. So the angle is 0.38 radians, and if you take the square root of 29, you have 5.39. So again, pay attention. Were you looking for exact values, or did you want decimal approximations? But here's the representation of this point with polar coordinates. So this angle here is 0.38 radians, and this r value is 5.39 approximately. Let's do another one. Let's use the point 4, -1. Have you caught on to the fact that we draw a picture each time? That's what you want to do when you're converting from rectangular coordinates to polar coordinates. So here's our problem this time. 4, -1. 4, -1 is down here in the 4th quadrant, where this is 4 and this is -1. Could have drawn it a little bit better so my triangle would be bigger. But let's find our r value. We know it's 4 squared plus -1 squared equals r squared, because it wasn't one of my special triangles. That gives us 17 on the left equals r squared. So we need to use r as plus or minus the square root of 17. Again, I'm trying to find this angle theta. So the tangent of theta equals -1 over 4. So the inverse tangent of theta, the inverse tangent of -1/4 will equal theta. So if you wanted an exact value for the representation for this point, we could write it as square root of 17, comma, inverse tangent of -1/4. But let's get some decimals for these. Square root of 17 is about 4.12. And the inverse tangent of -1/4, notice it's a 4th quadrant angle, so you'll get a negative value, is about -0.24. So here's our decimal representation of this particular point with respect to polar coordinates. So here's our r value, here's our theta. If you're asked specifically to have theta between 0 and 2 pi, and that's not uncommon, right? Maybe you want this to be your theta. Then we can simply add 2 pi to this, right? They are coterminal. So if you add 2 pi to negative 0.24, you would have an alternate representation of the point that would look like this. So our angle here is 6.04 radians, and this R value is 4.12. Let's do one more. Here we go. Let's talk about the point -7, -3. And our task is again to find the polar coordinates that would represent that point. So let's draw the picture. It's a third quadrant angle this time. So we're going to -7, -3. So -7, -3. And notice it is not a special triangle again. So I need my R and theta, but let's find R like we normally do. X squared plus Y squared equals R squared. So we have 49 plus 9 equals R squared. So we have 58 equals R squared. So R is plus or minus the square root of 58. Let's see, 58 is 2 times 29, so we can't simplify that. Now we need theta. For this particular problem, notice theta would look like this. We're over here in the third quadrant. So to find it, we do know that the tangent of theta from this picture would be y over x, so -3 over -7, which is of course 3/7. So notice this, when we find the inverse tangent of 3/7, and here's what I wanted to point out to you. When we use our inverse tangent notation, remember, you will always get an answer between -pi/2 and pi/2 if you're in radians. It will not give us a third quadrant angle. So you need to adjust for that. You take care, because this is going to give us a first quadrant angle, and we're going to need to add pi to it. The angle it will give us will actually be just the size of this angle over here. Keep that in mind if you have a point that is in the second or third quadrants, because remember, your inverse tangent will always give you an angle between -pi/2 and pi/2. So you just need to take care. So if I were going to write this as an exact value, it would look like this: square root of 58 for R, but theta is going to need to be the inverse tangent of 3/7 plus pi. I'm going to put the pi first. Plus the inverse tangent of 3/7. And again, it's because this inverse tangent will give us a first quadrant angle, and we need a third quadrant angle. So let's punch those values in. So we take the square root of 58, and we have 7.62 to the nearest hundredth. And I'm going to take the inverse tangent of 3/7, and I'm going to add pi, and I get 3.55 to the nearest hundredth. So this is one representation with polar coordinates for this point. The R value is 7.62, so this distance right here is 7.62, and this angle is about 3.55 radians. So let's summarize what we've done, and we've done it for numerous problems. Here's how we convert from rectangular coordinates to polar coordinates. Plot the point. Notice we did that each time. Find r. Always you'll have the Pythagorean theorem at your disposal right here. X squared plus y squared equals r squared. And we need to find theta. Tangent of theta always equals y over x, assuming that x isn't equal to 0. But if x were 0, you can just draw a picture and find the value pretty easily. Take particular care if your point is in the second or third quadrant, because you would need to add pi to your inverse tangent to find your angle. So what I'm saying is if you're in quadrant 1 or quadrant 4, you can let theta equal the inverse tangent of y over x, assuming that you're going to let your r value be positive. But if you're in quadrant 2 or quadrant 3, if your point is in quadrant 2 or 3, then you need to make sure you add pi to that inverse tangent. And I hope you go practice converting some rectangular coordinates to polar coordinates.